So again, a welcome to our attendees here today. I have opened up the chat so that you can interact and ask questions today. So please feel free to open up your chat and be ready with your questions. I'm happy to answer them today. All right, let's get started talking about CS Pathways K through 12. My name is Stephanie Bennett. I'm a professional development specialist here at CodeHS, and I'm really excited to join you today and talk about all of the great curriculum, these high quality instructional materials that we have available for you here at CodeHS. So I did drop a link to these slides in the chat. So if you'd like to follow along on your device with the slides, you may. However, I will keep broadcasting them here from my desk also. So for our half hour, 45 minutes here today, we're going to talk about what CodeHS is. I'd like to spend a little bit of time talking about the why behind computer science. You know, it's a relatively new subject matter in K through 12 education, and sometimes it's a good reminder to go back and think about the why behind what we are doing. We will talk about both state-specific and general pathways that our curriculum team has built here at CodeHS. And then I would love to spend a little bit of time also talking about how you recruit students to your CS program. You know, graduation requirements in computer science are definitely coming. I am actually based in Indiana, and we have a new computer science graduation requirement here in the state of Indiana, and that's wonderful. But, you know, not always the most motivating thing for students to get involved in a subject matter. So, you know, we will talk about how we can inform, educate, and excite our students about computer science, especially if you don't have a requirement driving them into your computer science programming. So like I said, we do have some options for interactions here today. The Q&A is open. And again, I've also opened the chat up to everyone so that you can drop questions there also. And so we'll go ahead and get started. If you are new to CodeHS, we would love to have you sign up for a free account at codehs.com/signup. Our teacher accounts are always free. Our middle school and high school curriculum is always free. And then once you explore our curriculum, fall in love with it, you know, we hope that you will also learn to love our teacher tools also that we provide in our pro licenses. So definitely sign up for a free account, explore the curriculum, see what all the excitement is about, and the great products we're building. And then if you're interested in a pro account and want to explore that more, I'll give you that information at the end of our session here today. So we also love to provide you with some evidence that you spent time with us here today. If you need to have hours for license renewal, or if you, need to show proof that you attended here today for any reason, you can click on the link in the chat and then get a certificate of completion for our time spent here together today. Now, you will need to be logged in to your CodeHS teacher account before you click on that link. And know that it's not a complicated process. You'll just see thank you for attending web page displayed once you click the link, and that's all you need. The certificate of completion will be emailed later. All right, so what is CodeHS? We are a comprehensive platform for teaching computer science K through 12. We provide elementary curriculum, middle school curriculum, and lots of high school curriculum. And that curriculum, of course, is all encompassed in a web-based platform where your students will log in and experience some really great computer science learning and practice, not only around coding, but also around other computer science topics like hardware and software, cybersecurity, and more. So very, very comprehensive curriculum. We also offer professional development. You know that. you're here today with me, both online and offline. And then, of course, I was talking earlier about our pro licenses and how they come with really awesome teacher tools and resources. And so definitely check out those options on the platform with that free account or log into your pro account here today. So our student-facing resources really provide great interactive and engaging learning experiences for your students. They get instant feedback frequently with our auto graders while they're coding, and they can, do all of their work on our just one website, which is great. And again, those tools for teachers around grading and academic integrity. And all of this is in our web-based platform. No additional downloads or plugins needed. So now that we know a little bit about CodeHS, let's talk about the why behind computer science. So I want to talk a little bit about the computer science landscape across the United States, and also consider how we might use backwards planning. We're teachers, we love our backwards planning. Consider how we might use our portrait of a graduate or our district mission and vision statements to help us consider why we're teaching CS, and also the building blocks that are needed in order to meet the goals of our portrait of a graduate or our district vision and mission. So let's start with the computer science landscape here in the United States. So really, really beneficial for me today. I was so lucky that CSTA has released their 2024 State of Computer Science Education report. And I just linked that in the chat for you. If you'd like to go download that report, it just came out very, very recently. And so I was able to update all this information and these statistics I'm going to share with you. So what you see up on the screen right now is a map of the US showing the percent of high schools in each state offering foundational computer science. And again, this was just updated in 2024. And in 2024, state budgets allocated more than $88 million to computer science education. And that allowed 60% of US public high schools to offer foundational computer science, which was up just a smidge from 57.5% last year. But know that, that's still demonstrative of some disparities that do exist to access to computer science education in high school. The survey found that 37% of middle schools are offering computer science, and in the past year, 6.4% of high school students enrolled in a foundational computer science class. Now, if all students took one computer science course in their high school career, then we could expect to see enrollment more around 25%, but it's just 6.4% of high school students. So I love those statistics just to kind of paint the picture of where we're at in this burgeoning field of K through 12 computer science learning and teaching. And I would also like to share the recent Reimagining CS Pathways report summarized why computer science education is a necessity for all students. They said, quote, "Students of all identities and chosen career paths need quality computer science education to become informed citizens and confident creators of content and digital tools." And we're going to get a little bit deeper into that why right now, because that strikes a chord with me. I believe that computer science education is important so that students can start seeing themselves not just as passive users of technology, but creators of and creators with technology. And when we equip all students with the knowledge and skills they need to excel in many different subject areas, we're going to touch on computer science skills inevitably in this increasingly digital world that we live in. I also love to advocate for the youngsters. Crucial early access and identity formation as a computer scientist can start as young as kindergarten. There are wonderful, engaging lessons, both online and offline, of course, for our youngest learners around computer science. We also can hook students who maybe traditionally wouldn't see themselves as computer scientists by cultivating student creativity and engagement in hands-on learning. Many folks who, didn't come from a computer science background um, find it an unexpected um, fact that creativity and computer science go hand in hand. I mean, there are 1,000 ways to solve a computing problem, right? A programming problem. And many of your students will show great creativity in solving problems in their computer science classes. Another piece of the CS education classroom that I love is developing a growth mindset. This is very personal for me. I will admit that I am a lifelong perfectionist, something I've dealt with my entire life. And it wasn't until I got to computer science that programming and coding just forced me to accept that things are going to be iterative. It's not going to be perfect the first time. When I'm coding, when I'm troubleshooting with a device, it's got to be iterative. And I cannot tell you how really proud of myself I am that I've kind of grown in that capacity, that now I'm willing to try things even if I'm pretty sure they're not going to work. And so really, I hope you can tell how personal this one is to me. I absolutely will advocate for from here to eternity about this growth mindset piece in computer science. Also, something I'm very passionate about is computational thinking. So I believe firmly that computational thinking has so much to provide in interdisciplinary connections and helping students have a shared vocabulary around what proficient problem solving looks like. So computational thinking involves decomposing big problems into smaller pieces. It involves abstraction by only focusing on the important parts of a problem. It involves pattern recognition. It involves algorithmic thinking, making sure that the steps we're planning to solve a problem are in the right order. We haven't missed any so that we always get this outcome that we're looking for. And I think that those computational thinking practices and that vocabulary, if we can help students establish the vocabulary of what they're supposed to do when they approach a problem, will make it so much easier for teachers and students to have discussions about problem solving, not only in computer science, but in other subject areas also. So I'll step off my soapbox now. I'm just really passionate about computer science education. And let's talk about backwards planning. And as we're approaching building a computer science pathway, talking about the why and the what. So I want you to think about your district vision and mission, or your portrait of a graduate if you have one. I want you to think about any kind of social emotional learning district initiatives or 21st century skills initiatives that your district is implementing. And also thinking about enrollment, enlistment, employment, after secondary education, where are our students going? That is the whole purpose of school, right? To produce citizens who can contribute through enrollment, enlistment, employment, and through their ideas and through their work ethic. And so thinking about the students that you want to see leaving your district upon graduation, how can we backwards plan a CS pathway that follows along with your portrait of a graduate, that supports your 21st century skills and your district initiatives around enrollment, enlistment, and employment? Computer science is absolutely pervasive in all industries and many, many careers these days. And so if we're thinking about the students who are leaving our doors after graduation, what are the skills and knowledge we want them to have? What are the practices we want them to take with them out of the classroom? And so thinking about your graduates, how do we backwards plan to that success? And a lot of times, we have to measure those things in test scores, and I hate that. But I do want to prompt your thinking with, potentially we want students to be proving their skills, proving their knowledge and ability to implement practices via maybe AP tests or certification tests in industry. And if that is our goal, how do we plan up to that moment? And I wanted to share this quote from Sean Razor, who teaches in California. He said, I had 101 students take the AP exam and 95 passed with a 3 or better. It is great to be able to know that we are providing them with such solid content throughout the year thanks to CodeHS. And so, if AP exams are part of your graduation requirements, if they are a symbol of how well your students are doing, as they are in many cases. They are something to brag about, and this teacher should be so proud of this accomplishment. And so, think of your graduates, think of the skills, the knowledge, the practices you want them to possess and take out with them into the world, and let's backwards plan from there. Whether the pinnacle of your students' CS journey is AP exams, whether it's certifications from industry, let's backwards plan from that moment. All right, so we've talked about the why. Let's get into the details. We're going to start with state-specific pathways that CodeHS has built, and then we'll get to some more general pathways that CodeHS has built for your K-12 students. So this first website I'm going to share in the chat is a place where you will be able to see what courses and potentially what pathways CodeHS has built, where we have aligned courses and or whole pathways to your specific state standards. And so definitely check out the website, codehs.com/states. Click on your state and see what kinds of courses we have aligned to your state standards, and see if we have a recommended state pathway for you. Give you a minute to do that. Again, so these are the states that we have specifically aligned to state standards for some of our courses. If there is a pathway also aligned and available, it will show up also on that page. And so I would love to just give you an example of what that looks like here. So let me pop over to this tab. And I'll show you first with Kentucky. And so Kentucky, we do have some courses aligned to Kentucky computer science state standards. Fortunately, we don't have a pathway built specifically for Kentucky. But then I'll show you again, Indiana's where I'm based. And I know that not only do we have courses built for Indiana specifically for computer science standards alignment, but we do also have Indiana pathways. And so this page looks like this. You can click into any of these courses to learn more about them. So that's how to use that wonderful website from our from CodeHS. So hopefully you do find some state-specific content that's great for you. If not, we can take a look at what we are offering in our general pathways. So we do offer elementary K-5 computer science. We also offer options for our middle schools. And then we have several pathways, 4 in fact, that we'll talk about today for our high school settings. And so let's start with the elementary side of our curriculum and offerings. We offer 2 course pathways. We have a computer science pathway. So that would be lessons specifically geared towards teaching computer science concepts like sequences or loops or conditional statements. There are also some lessons included in there that are unplugged. So maybe you'll get into a little bit of hardware and software, things like that. But we do also offer an interdisciplinary computer science pathway for elementary school. And this would be great if your teachers in elementary schools are just struggling to find time to teach computer science. That is definitely the #1 blocker we hear from elementary school teachers, is that they don't have time to teach computer science. So what we've done is we've taken common standards for science, ELA, math, and we've created some computer science lessons that fit in with those subject matter concepts. So I'll show you what I mean here. I'm going to take you to these sample elementary student projects. So this first one is going to be a Scratch Junior game where we're just navigating through a maze. So when I start the program here, I am this baby up here in the left-hand corner, and I'm going to navigate using these dots that have been programmed and move the baby through the maze. And this is one of our computer science lessons. Oh, and I messed up and got sent back to the start. So this is a computer science lesson where students are learning how to program multiple sprites in Scratch Junior. Now, this second example I'm going to show you and this third example I'm going to show you obviously have some more interdisciplinary connections. Here we are using Scratch to create a sort of click and learn interactive animation to learn about ecosystems. So when I click on the sun, oh, I have to click the flag first. The sun says, I produce light, and we can click the numbers 1 through 4, or click these sprites and see, oh, I pressed 1. I'm a producer. I use energy from the sun to produce food. So the plant is the producer. And then when I press number 2 on my keyboard, I'm a consumer. I get my energy from eating plants. So obviously you can see the great science connections there. And then this one is a math interdisciplinary lesson where students are practicing with fractions. So when I click the green flag, I'm asked to move Gobo here, this sprite connected to my mouse cursor, to 1/4. And so if I put Gobo on half, well, it shows me half the pizza, but we're not quite at 1/4. So if I move Gobo to 1/4, I get a little sound indicating that I have successfully found 1/4. And when I move Gobo now to 3/4, I get my little sound. Yay, I did it. So definitely some very cool interdisciplinary connections available in our elementary platform. So that's what it looks like from the student side, what project students build. And on the teacher side, we have ready to go slide decks that require very, very little preparation for teachers. We also provide lesson plan documents with standard alignments included. We provide assessment rubrics for students' programs, starter code, so that students can really focus on one coding concept at a time. We're reducing that cognitive load via those starter code programs. We also provide example projects where the code is complete, so the teacher can reference what everything should be at the end. And we provide slide decks for students in both English and Spanish. So if you have biliterate students in your community, we do provide those translated slide decks. So that's a very short recap of our elementary school offerings, and we'll move on to middle school next. Remember, you do have access to the chat. If anybody has any questions while I go along, just pop them in there. And so for middle school, we have a very customizable approach to middle school. So we know that every middle school approaches computer science in a unique way. And so I'm going to start here with kind of our smallest offering. It's very customizable. And so whether you need 5 hours, 10 hours, 30 hours of curriculum, our middle school mix and match course is going to be your go-to for those smaller contact hours needed with students. And so I will put a link to our middle school course catalog in the chat. So if you are interested in taking a look at this middle school curriculum while I'm talking about it, please feel free to click on that link in the chat. So let's talk about mix and match. So this course contains all of the CodeHS introductory middle school content. And again, it takes a very modular approach to that content where each of the modules contained in the mix and match course are about 10 hours of content and introduce students to a specific topic within the field of computer science. Now, because it's modular, teachers can remove and reorder the modules to create a course that meets the needs of their students and class setup. These lessons were designed specifically for middle school students, and they will explore topics in a variety of engaging and interactive ways. So this course utilizes a blended classroom approach. The content is a mix of web-based and physical activities, and depending on the chosen modules, students may write and run code in the browser, create websites and digital presentations. They might complete interactive activities online or engage in in-person collaborative exercises with classmates. And your teachers will be able to utilize the tools and resources provided by CodeHS to leverage time in the classroom and give focused one-on-one attention to students. So definitely recommend this if you just need a little chunk of computer science for your middle school students. Now, if you're looking for a little bit longer course, maybe a semester elective, then we also have some options in our middle school pathway. So our CS Explorations 1 course is about 50 hours of content, and this course is an introductory course for early middle school students. It's great for students who are completely new to coding or for students who are continuing on their coding journey, maybe coming from block coding and starting to transition into text-based coding. So students learn the basics of programming with Carol and Tracy, our two CodeHS mascots. They also learn computing and digital citizenship. The modules in this course are standalone modules and can be taught in any order. The only exception there is that students need to have completed Carol Adventures 1 before starting Carol Adventures 2. In CS Explorations 2, this is another 50-hour class. It's a course, again, introductory, but for upper middle school students this time. It, again, works for students who are completely new to coding or are continuing their coding journey. Again, students start with the basics of programming with Carol the dog and learn how to code within the context of art and game design. Students also explore how the internet works and how to make web pages with HTML and CSS. It is 50 hours, and those 5 modules in the course are standalone modules and can be taught in any order. We do recommend, as maybe a prerequisite, that students complete CS Explorations 1 before completing CS Explorations 2. However, CS2, it does include optional introductory materials to support students who have not had the opportunity to complete CS Explorations 1. So finally, on this list here for a middle school pathway, we also include Python Basics with Tracy 1. This is a 60-hour course. And this course teaches students the basics of programming in Python. Students learn Python commands, functions, control structures, and user interaction by solving puzzles and writing creative programs for Tracy to follow. And this does not have any prerequisites. It is designed for complete beginners with no previous background in computer science because it is highly visual, dynamic, and interactive. So it makes it really engaging for those students who are new to computer science. Now we do have an option 2 here where students maybe take CS Explorations 1, Python Basics with Tracy 1, and then Python Basics with Tracy 2. Tracy 2 is again a 60-hour course, and it teaches students extended concepts in Python. Students learn how to use lists, manipulate strings, and work with files by solving puzzles and writing creative programs for Tracy to follow. So the content taught in the Python Basics with Tracy 1 course should definitely be covered before beginning Tracy 2. All right, so what if you need a full year elective for your middle school? Well, then you will never run out of curriculum with CodeHS. We have lots to offer your middle school students. So if you need 3 years of full year electives, this is what I would suggest. I would do CS Explorations 1 with 6th grade, do CS Explorations 2 with 7th grade, do Python Basics with Tracy 1 in 8th grade, but add in additional shorter curricular units from our catalog. So examples might be programming with microbit. Now, of course, those require hardware, but if your teachers have access to microbit hardware, then it could be very, very cool for your middle school students to have that hands-on computing experience. Maybe you select our Introduction to AI for middle school course. That's a brand new one we released this year, 20 hours long. Maybe you want your students to really dig into web design. We have a middle school course for them. And then Roblox. Now, I will say Roblox does require an additional software download, but if you have questions about that, I'm happy to answer it. So what does this look like on the student side? We'll have an example GIF there of Carol moving around a world, depositing balls as she goes. And so Carol is really interactive, really visual and fun for students. And then we also have the Tracy modules, of course. So let me pull up an example of what these programs look like. So when I click run here, you'll see Carol in this world with a tree where she's got to build a ladder to get up to that gray dot. Really fun and visual for students again. Then we have a drag and drop area here. I do not know the right answers to this, so I'm just going to demonstrate the drag and drop. And then we have an example of an animation made with Tracy the turtle. So you can see just how visual and fun these programs are for your middle school students. All right, next we'll talk high school. So we have 4 pathways, like I said, for high school computer science. And again, thinking about your portrait of a graduate, thinking about your skills and your knowledge you want students to leave high school with, we can kind of incorporate lots of different computer science subject fields of study into your curriculum and offerings, and help students become really proficient and successful and ready for careers and college. So this first pathway I'm going to talk about is the AP Computer Science pathway. And you can see there that in 11th grade, we suggest students sit for the AP CSA exam, and we have a whole course built out for that called Nitro. And so if that is something you're interested in your students preparing for, then let's work backwards from Nitro. We should have them sit for AP CSP and Python, and also take Intro to Computer Science and JavaScript Corgi. So the Corgi course is a full year, 125 hours, really basic introduction to computer science. Lots of programming with Carol in there, and graphics also, so very visual and fun, and in the Intro to CS and JavaScript course. The AP CSP course is 125 hours. I think some schools do teach this course in a semester, but the AP CSP course is the newest AP course from College Board, and it introduces students to foundational concepts of computer science and explores the impact of computing and technology on our society. So really, really interesting topics and discussions and debates for students to have in an AP CSP course. We're recommending here that students use the Python programming language, although we do offer JavaScript, AP CSP, Python, AP CSP, and a cybersecurity AP CSP. So then students would tackle our AP CSA course. It is 130 hours of content provided from CodeHS, so a year-long course. And it is designed to help students master the basics of Java, and it equips them to successfully pass the College Board APCSA exam at the end of the school year. So definitely some prerequisites here for APCSA. We recommend that students complete students in the APCSA course have successfully completed a first-year high school algebra course, because it's important that students understand that computer science builds upon a foundation of mathematical reasoning. And so students will find much more success in APCSA if they have taken algebra. And also definitely we recommend that they've taken at least our Introduction to Computer Science course, and potentially, like in this pathway, the APCSP course also. We round this pathway out with data structures in C++. This is another 130-hour full-year course. And this one focuses on different ways to store data beyond just traditional variables and lists. And so students get into maps, queues, sets, and apply them in larger real-world assignments and projects. So a hefty course at the end of this pathway, but your students could come out of it with 2 AP credits. So that's our first flavor, our first pathway for high school. We also have a cybersecurity pathway, and it starts with Web Design Picasso. It's a 140-hour full-year course where students use HTML and CSS to design websites. No prerequisites for that one. It could definitely easily be a freshman level course. Fundamentals of Cyber is a 125-hour course, and this is a really fun one. We've just revamped this one this summer, so it's very interactive, includes some labs for students and some really fun activities like a capture the flag. If you're into cybersecurity, you know what I mean. APCSP, again, I was saying when we were talking about APCSP Python, we have different flavors of APCSP. Here is our cybersecurity version, and there are no official prerequisites for the APCSP course. It is meant to be a first-time introduction to computer science, but we do recommend that if possible, students have taken our Intro to CS course prior to any AP courses they take. And then students would round out this journey with our advanced cybersecurity course. This is 145 hours, and it is the capstone of this pathway. Students will learn advanced topics in the field of cybersecurity, including advanced cryptography, network risk assessment, and cyber defense. And they should definitely have taken fundamentals of cyber before attempting advanced cybersecurity. Now you'll see that I've included on this slide 2 of our certifications. So CodeHS does offer certification exams. We have 7 state-approved certification exams across different programming languages, including Java, JavaScript, Python, HTML and CSS, and cybersecurity. Students can take or retake as many certifications exams as they want using our vouchers that your district would purchase with a license from CodeHS. These are really flexible. Exams are given on your schedule at the time you select as most suitable for your students, and your teachers and students receive a pass-fail notification after the exam. After students pass, they receive a congratulation email, including a downloadable certificate to keep with them for their records. So cybersecurity level 1, you would sit for that exam after completing fundamentals of cybersecurity. And I will give you a link to our knowledge base article in the chat about the exam. Cybersecurity level 2, you would sit for that exam after completing the advanced cybersecurity course. And so again, I will put a link to more information about this certification in the chat. All right, I'm running out of time here, unfortunately, but I do want to point out we have 2 additional pathways. We have a Python pathway, looks very similar to our other pathways, except this one really helps students gain lots and lots of confidence and mastery in just one language, Python, programming here. And we do have a certification available to go along with students sitting for the AP exam. So I'll put a link to that level 1 Python certification in the chat if you're interested. So again, students could come out of here with an AP CSP score and a certification from CodeHS. And our final pathway we'll talk about today is our web development pathway. This one is really, really engaging and interesting for students. It's so visual. When I started my computer science journey, I started in web development and JavaScript, and I loved it because it was so immediately rewarding. You could just see that web page you were building right away, and I loved that. So highly recommend our web development high school pathway. Picasso is a 140-hour full-year course. Corgi, we've already talked about when we were talking about our AP CSA pathway. The web development course is a 145-hour full-year course, and mobile apps is a 125-hour course. Very fun for students to get to that mobile apps course for sure. So we do have 2 certifications connected to our web development pathway. The Web Design Level 1 certification exam is approved by the Virginia, Texas, and South Carolina Departments of Education. So cool recognition there. And students would take the Web Design Level 1 exam after taking the web design course. Our Web Development Level 1 certification exam is approved by the Virginia Department of Education and the South Carolina Department of Education, and students would sit for that after taking the web development course. So if you would like to explore these pathways in greater depth or any of these courses in greater depth, I have put a link to our catalog in the chat filtered to those high school courses. So I'm so sad we're out of time to talk about ways to grow your CS program, but if you have access to the slides, I will put that in the chat one more time before we leave, then you can check out these great links and resources I have included here for you to peruse. So thank you so much for joining us today. I want to give a little shout out to some other resources we have available to you. You can become a CodeHS certified educator, earn a micro-credential with CodeHS, join our Facebook group, or follow us on social media. So let me get you some links here in the chat if you are interested in any of these additional resources. We do also offer more PD, as I'm sure you are aware, so check out our free PD coming up. And finally, I will just ask that you take a minute to give us some feedback on this session. I hope that I have given you lots of information on how to plan out your K through 12 computer science pathway for your district and given you some options and some useful information. If I've done that, I would love to hear about it. If you were expecting a little bit different information out of this webinar, I would also love that feedback. So please take a moment here before we leave to fill out that webinar survey. I'll also put the certificate of completion link in the chat once again. We have, like I said, additional free PD opportunities coming up, so I will put a link to those in the chat. Check that out. We do have our Coding Coast to Coast road trip happening right now. Our CS ambassador is on the road. He's left the Midwest, headed up to New England to do lots of school visits. So if you are interested in Blake, our CS ambassador, coming to visit your school, definitely check out our road trip and put in an application to have him come visit. And finally, right from the top of the session, I promised you that I would provide you with a way to find out more about bringing CodeHS to your school or district and those fabulous pro tools we have available. So if you'd like to learn more, check that out. And thank you so much for being here today. I appreciate the time we've spent together. If there are no questions, then we're free to go. Have a great evening.